All right, guys, in this video, we're going to clean out a little bit of the cobwebs from before our 2-week hiatus. Right before that, we were looking at solving multi-step equations. We were about to get into some of the really tough ones. So before we do that, we want to kind of go back, make sure that you remember some of the strategies and skills that we taught you right before we had that COVID-19 break of everything. So I'm just going to go through 4 examples that are on that note sheet. You'll notice that a couple of them are listed twice, and that's because I want to show you some of the alternate strategies that you can use when you're solving equations. Got a couple pro tips in here. So the first one, pretty straightforward example, 2-step equation, 2x plus 7 is 35. We talked about how you have to kind of go in reverse order of operations, right? So we're going to get rid of that constant plus 7 first. We're going to eliminate the constant. We're going to try to get x by itself. So first I'm going to take away 7 from both sides. That will eliminate the constant. That becomes 0, and that leaves me just 2x on that side of the equation and 28 on the other when I subtract 7 from that as well. Now I have 2 x's are worth 7, so 1x, if I divide by 2, has to be worth 14. So we divided both sides by 2. This was that whole idea of balancing that we talked about right before break. Trying to eliminate everything that's with x so that you can get x by itself, isolate the variable, inverse operations, all that good stuff. Second example looks pretty easy too, has a couple of things that people mess up in here. First thing is we have to get rid of the constant first here too. The constant is 3, and the only way to get rid of 3 is to subtract 3. Some people think that because there's a subtraction sign in the problem that they should be adding 3. But if you add 3 to 3, you get 6. We need that to be 0, so we want to take 3 away from 3. That minus sign actually belongs to that 5x term. It belongs to the algebraic term there. So it stays with it too. You have to bring that minus sign down. That is now a negative 5x. It's the same thing as if it was plus negative 5x. That negative stays with it. It's still with 5x. I'm going to divide by that negative 5 because I need to get rid of not just the 5 but the negative 2. I need it to be positive 1x. So I'm going to divide by negative 5 and I'm going to get negative 7/5 is what x is. Now of course you might have also wrote that as negative 1.4 or even negative 1 2/5. It doesn't matter. All 3 of those answers are acceptable solutions to this problem here. So 2 things you can get caught on there, that constant being 3 and having to subtract it and then remembering to bring that negative sign down with that 5x. Now we get into the last 2 where I have them listed twice, and I have that for a specific reason because I want you guys to know different ways to solve the same type of problem. So option 1, here I have y over 6 minus 2/3 is worth 2. So option 1 is to just do the problem as is, do it straight up. So if I look at the problem, I can see, okay, I have to get rid of the constant. The constant is minus 2/3. I'm going to get rid of a minus 2/3 by adding 2/3. So that gives me y over x. It gives me y over 6 is equal to 2 2/3 because when I add 2/3 and 2, I get 2 2/3. So now I have y divided by 6, so I need to do the inverse of that. I'm going to multiply by 6. That's going to eliminate that divided by 6. And then I have to do 2 2/3 times 6. There's the little bit of a rub there, and that's when the second option you won't have to do that. If you have a calculator, it's not too bad. It ends up being 16 when you do the math. So here comes your pro tip for this same problem. We're going to do this problem again, but now we're going to do it with a pro tip. Here's your pro tip. Eliminate all the fractions. And you can get rid of fractions in an equation by simply multiplying everything in the equation by the least common multiple of the denominators. So what I mean there is if you look at the denominators in the problem, it's 6 and 3. Number 2 is whole, so I don't even care about it. I'm just looking at the denominators. I see 6 and 3. I know the LCM of 6 and 3 is 6. So if I multiply those terms by 6, it will make them into wholes. But because I want everything to stay equal, I need to multiply everything by 6. So I'm going to multiply 6 times everything in the equation. I'm going to expand the 6 to both terms on that side of the equation. Y over 6 times 6 is y. 2/3 of 6 is 4, so it's minus 4 when I do that math. And then 2 times 6 is worth 12. So just by being able to do that, I've made the equation into y minus 4 is 12. Obviously, I'm going to add 4, and that's going to give me y is 16. So I really simplified the problem just by doing that pro tip in the beginning. And when we get into some of the bigger ones, if you can successfully do that, you will make problems so much easier to tackle. So it's a good one to practice, and we hope that you practice that today on some of the independent practice work that we have. Final example. I have this one listed twice as well. So here it is, 2x plus 3.5 minus 1.5x equals 8.5. So option 1, do the problem straight up, do it as is. So if I look at this, I will notice that on the side that has x, there's actually 2 like terms there. I have a 2x and I have a minus 1.5x. So I can combine those terms first, and I should combine those terms first. That gives me 0.5x when I have a positive 2x and a negative 1.5x. That's positive 0.5x. Still have that constant plus 3.5. Now I'm going to go ahead and get rid of that by subtracting from both sides. 8.5 minus 3.5 is 5. And then I have 0.5x equals 5. Now here comes a little trick. I could just divide by 0.5 right now, but I'm a smarty pants. That's half of x. So if I double it, I'll get a whole x. Whoa, blew your minds. I didn't just go into autopilot and divide by 0.5x. I could divide by 0.5. But if you double, you're going to get a whole x, a 1x. So always be thinking as you're solving equations. You always want to be thinking about what strategies you can do to kind of get there. You don't always have to go into autopilot mode. Now I have this one listed twice. Here's your last pro tip of the day. Same problem. I have decimals. Get rid of all the decimals in the problem. Well, how do you get rid of all the decimals in the problem? Well, how did we get rid of all the fractions in the problem? We multiplied everything. So if I multiply decimals, I could do it times 10 if everything goes to 1 decimal place. I could do times 100 if things go to 2 decimal places, right? Or I can multiply by something else, as long as everything becomes a whole number. Now that something else here is kind of the trick, because if I look at this problem, I notice that everything ends in 0.5. So if I double everything, then everything will be whole. So that's what I'm going to do. I'm going to double everything in the problem. So I put times 2 on both sides of the equation. I'm going to expand that times 2 to all the terms on that side. So if I double 2x, I'll get 4x. If I double 3.5, I get 7. If I double negative 1.5x, I get negative 3x. And then if I double 8.5, I get 17. So now I have an equation that only has whole numbers in it, and it will have the same solution. Again, I still have these 2 like terms. I can combine them, but this time now it's okay. 4 minus 3, well, that's 1x. And then I just have to move that plus 7 constant by taking it away, and that's going to give me x is 10. And that's it. I mean, that's all there is to it. So that's a pro tip too. You can eliminate fractions. You can eliminate decimals. You just have to remember to multiply everything in the equation when you're doing that so that you ensure that your solution doesn't change. So hopefully you can do the 4 examples that follow this, clean out some of the cobwebs, and then we'll get into the fun stuff as we keep moving forward. All right, good luck.